Hello, and thanks for watching my Module 9 presentation video. My name is Josh Puhala. Today I'm going to be doing a proof by induction that shows that for any positive integer n, 7 evenly divides 9 to the nth power minus 2 to the nth power. Since this is a proof by induction, we're going to start with the pretty standard two steps that you start with for that. So for the base case, we want to show that for n equals 1, 7 evenly divides 9 to the nth power minus 2 to the nth power. So when we plug 1 in for n, we have 9 to the first minus 2 to the first is just 9 minus 2, which equals 7, and 7 evenly divides 7 one time, so that checks out. We go to our induction step. So we'll change the variable, assume that k is a positive integer and 7 evenly divides 9 to the kth power minus 2 to the kth power. So we want to prove that 7 evenly divides 9 to the k plus 1 power minus 2 to the k plus 1 power. Since 7 evenly divides 9 to the kth power minus 2 to the kth power, 9 to the kth power minus 2 to the kth power equals 7m for some integer m. So here we start to work on figuring out a way to plug this in. So we start with 9 to the k plus 1 power minus 2 to the k plus 1 power and show that that's the same if we add 0 to it. So adding 0 can be the same as adding 9 to the k minus 2 to the k minus 9 to the k plus 2 to the k. Each of these cancel out each other, and that's essentially 0 on that entire last 4 terms. This step here just shows kind of rearranging the terms that we already have here to group 9 to the k plus 1 minus 9 to the kth power, the 2, and then importantly we leave these last two here, 9 to the kth power minus 2 to the kth power, because that is our inductive hypothesis. And the next step shows a little bit of factoring along with introducing that inductive hypothesis. So for these first two terms, we factor out 9 to the k power, which leaves us with 9 minus 1, minus 2 to the kth power times 2 minus 1. And then here we replace our last two terms with 7m, because that is our inductive hypothesis. So moving forward, just simplify these. Show 9 to the kth power times 8 minus 2 to the kth power times 1 plus 7m. And then here we are basically finished. So we're just showing that if we take 7 out here, factor out a 7, we are left with 7 times 9 to the kth power times 8 divided by 7 minus 2 to the kth power times 1/7 plus m. Since we know m is an integer, we know k is an integer, all of this stuff in here is an integer, and we have 7 times an integer, which means that all of this will be divisible by 7. And that is the proof. So one issue that I had when working through this was trying to figure out how to factor out the 7. But once I realized that you could just create fractions, that worked out pretty simply. It actually took me working out an entire other proof uh, to realize that I could do that. But once I got it figured out, it worked out for me in the end. Thanks for watching.